for the NCBN 0324 and Math 1324. Okay, the topics that we're going to cover, to start off, is going to be plotting or graphing by plotting points. Okay, there's like 2 or 3 different ways to graph. It depends how the equation is set up. And number one, I'm going to show you how to graph by plotting points. So it only takes 2 points to graph, but here I'm going to use 4 points for this example here. So I'm going to use -1, 0, 1, and 2 for x. So here's my equation, y equals to -2x plus 3. So what I'm going to do here, I'm going to plug in -1 for the x's. This gives us y equals to 2 plus 3, so y equals to 5. So when x is -1, y is 5. So the point is -1, 5. I keep repeating this process for 0, 1, and 2. So let's do it when x is equal to 0. Right, y will equal to 3. So when x is 0, y is 3. So the order pair point is 0, 3. When x equals to 1, we're going to plug in the x and the function for the x's. We evaluate, so it's going to give us y equals to -2 plus 3, so y equals to 1. So when x is 1, y is 1. So the point is 1, 1. Now finally, we're going to evaluate it at x equals 2. We're going to plug in 2 for the x's. So it's going to give us -4 plus 3. So y equals to -1. So when x is 2, y is -1, which results in the order pair of 2, -1. Now we're going to graph them, each point, right? So -1, 5 is -1 for the x and 5 for the y. So it's going to be all the way up here. Then comes 0, 3. So my x is 0 and my y is 3. Then it's 1, 1. So x is 1 and y is 1. And finally, we have x equals 2 and y equals -1. And we connect our line through all the points. That's how you graph by plotting points. Okay, now I'm going to use another method of graphing. This method is by using the slope-intercept form, which is y equals to mx plus b. So in this form of graphing, I need to know what the slope is. The slope is the m, which is -2. So the slope is -2. We put it as a fraction because it's going to be the rise over the run. So in other words, the slope will be going down 2 down and 1 to the right. Okay, but from where? From the y-intercept, which is my b. The b is the y-intercept, which is 3. And my starting point is going to be 0, 3. So this is my starting point. So I'm going to go to the graph. And I'm going to go to 0, right? 0, 3 is my starting point. So I'm going to go to 0, 3, 0 for x, and 3 for y. So it's going to be right there. Then from this point, I'm going to go down 2, which is 1, 2, and 1 to the right. And we connect the 2 points. That's my line. That's the same line that I got in the other word, in the previous slide. But for there, we did it by plotting points. Okay. Now let's do another example here, number 3. So my slope is 3, and my b is -5. That means my m is 3, right? So it's going to go up 3 and 1 to the right. From where? From the b, which is the y-intercept. So the y-intercept is 0, -5, and this is my starting point, 0, -5. So I'm going to go to 0, -5, which means it's the x is 0 and the y is -5, so I'm going to go down. There's my point. Then I'm going to go up 3, 1, 2, 3, and 1 to the right. There's the other point, and we connect the lines. The points. That's my line. Number 4, we're going to graph y equals to 4. Okay, if you notice, there's no m, right? The m is equal to 0, only the y is equal to 4. So my slope is 0, and my b is 4. It's going to be a horizontal line. When you have y equals to a number, like to a 4 or any a number, is going to be a horizontal line. So this is my starting point, 0, 4, and it's going to be a horizontal line, so I can just pick another line, another point on that's equal to y equals 4. So my line will always be a horizontal line, including the b, which is 0, 4. Okay, this is what I what I put here. Observation: when the equation is y equals to a number, right? It can be any number. The horizontal line will be at that number. Okay, which is, in this case it was 4. Y equals to 4, so it's going to be a horizontal line at 4, at y equals 4. Now look at number 5. Graph x equals to -2. So my solution is, right, x equals to -2. That means the slope is undefined, right? And it's going to be a vertical line. A vertical line where? At x equals -2. So we're going to go to -2 for the x, and we're going to do a vertical line at -2. And here's the observation. When the equation is x equals to a number, the vertical line will be at that number. Okay. Now let's do number 6. Graph -5x minus 2y equals to -10. And this way, we need to put it in y equals to mx plus b in slope-intercept form. So we have to isolate the y. So first of all, I'm going to add 5x to both sides. Will give us -2y equals to 5x minus 10. Then I'm going to divide every term by -2. So we're going to get y equals to -5 over 2x plus 5. Now we have it in the form y equals to mx plus b, which is a slope-intercept form. Now we can know what the m is. My slope is -5 over 2. And my b, oh yeah, or it can be the -5 over 2 is going to be 5 down and 2 to the right. And the b is 5, which is the y-intercept, and this is my starting point. So my starting point will be 0, 5. So x is 0, so I'm going to go all the way up to the 5 on the y-axis. There's my point. Then I'm going to go down 5. So it's going to be 1, 2, 3, 4, 5, and 2 to the right. 1, 2. And just put that point there. And we connect the 2 points. So that's my line. Now, there's another way to graph, which is by finding the x and y intercept. I always tell my students, if the equation is in this form, in the form ax plus by equals c, then perhaps it's easier to use the x and y intercept. Okay, for this example, number 7, I'm going to show you all the work. And then on the next one, number 8, I'm going to do it by an easier method, okay? But without showing the work, but actually getting it kind of quick. But for now, let's show all the work. So find the x-intercepts. So you let y equal 0 and solve for x. Right, so to find the x-intercepts, again, this is a rule. We let y equal 0 and solve for x. So we're going to plug in 0 for the y. This becomes -5x equals to -10, right? We divide both sides by -5, and x equals to +2. So the x-intercepts will be 2, 0. Right, so to plot it, let me go back real quick, previous. So to plot it, right, we're going to go to 2, 0, so we're going to go to the graph, and the x is 2 and the y is 0, so it's going to be right there where the red point is. Now we're going to find the y-intercept. To find the y-intercept, you're going to let x equal 0 and solve for y. So we're going to let x equal to 0. This becomes -2, y equals to -10. We divide both sides by -2. So y equals 5. So when x is 0, y is 5. So this is my y-intercept. So we're going to go to 0 for x and all the way up 5 for the y. And we connect the 2 points. That's my line. If you notice, this was the same one as the one that we just did. But for the other one, on number 6, we did it by solving for y, or put it in y equals to mx plus b form. And then we graphed it right, but you can do it this way. Okay, now let me do the next one. Okay, and this one, we're going to do the same thing, okay? Graphing by using the x and y intercept. But this one, I just came up with the name, for it. I call it the cover. I know it's not in the book, the cover, but I just made it up because really you cover the x's or you cover the y's to find the intercepts. Let me show you how it works. Okay, to find the to find the x-intercepts, you let y equal 0. So this is what I mean by cover, right? So I'm going to cover the y, because if it's 0, it's gone. Then in your heads, you can divide both sides by 3, right? So x equals to 4. That's why I call it the cover and the cover, because you're going to cover the y's for the x-intercepts. Then you're going to cover the x's for the y-intercept. So we know x is 4. So the x-intercept will be 4, 0. So we can plot it. 4, 0 is going to be 4 for the x. Let's go to the right. 4, and the y is 0. Right there where the red point is. Now, to find the y-intercept, right, we're going to let x equal 0. That means we're going to cover the x, right, because 3 times 0 will give us 0, so we can just cover it. Now, in your heads, let me go back. In your heads, right, we can divide both sides by -4. So y equals to -3. So the point is going to be 0, -3, and that's my y-intercept. So we're going to go to 0 for the x, and we're going to go down 3 on the y. And we connect the 2 points. And again, I call this a cover, okay, because at times some of the students enrolled in 1324, they don't really follow some of the definitions and some of the concepts. So I always try to, I always explain the concepts, but at times I come up with different ways for them to understand it. And up to this point, the students like to use this method, which is the cover, okay? But I just made it up. Okay, now, so let's go to number 9 then. Now for number 9, for the next, I think, 4 problems, we're going to be finding the slope. So this is a formula for the slope. It's the change in y over the change in x, which is y2 minus y1 over x2 minus x1. So for example, number 9, right? They want us to find the slope with a given line. So here we have 9, 0, and 12, 12 are my 2 points. So then we can say that my x1 will be 9, my y1 will be 0, my x2 will be 12, and my y2 will be 12. All right. So let's plug them into the formula. So my y sub 2 will be 12. My y1 is 0. My x2 is 12, and my x1 is 9. So 12, it will give us 12 over 3. So the answer will just be 4. My slope is 4. Okay, now this is number 10, in the same manner. So my x1 is -5, my y1 is -2. My x2 is -4, my y2 is 11. Let's plug him in. My y2 will be 11 minus -2 over -4 minus -5. So when you have a minus and a negative, it becomes positive. So it's going to give us 13 over 1. Because same thing here on the denominator. The minus a negative, this turns to a positive. That's why this becomes -4 plus 5, which will give us a 1 on the denominator. So it'll be 13 over 1. So my slope is equal to 13. Okay. Now this is number 11 and number 12. Okay, now again, same thing, right? So my x1 is 5, my y1 is 3, my x2 is -7, and my y2 is 3. So let's put them into the formula. So it's going to be, let's see, y2 is 3, y1 is 3, so 3 minus 3, over x2 is -7, and x1 is 5, so it'll be -7 minus 5. If we notice, it's going to give us a 0 on the numerator. So it'll be 0 over -12, my slope will be 0. But again, I tell my students, show my students observations also. I tell my students, if the y's on each point repeat, then the slope will always be 0. So I always tell my students to look at the 2 points. If the y's repeat, like in this case, you should know that the slope will be 0. And then if the x's repeat, it's going to be something else, which I'm going to show you. I'm going to prove it, to you on number 12. But if the x's repeat, it's going to be undefined. Okay, so let's do number 12, and let's see what it gives us. Okay, we notice, right, that the x's repeat. Let's see what it gives us when that happens. So again, my x1 is 1, my y1 is 2, my x2 is 1, and my y2 is negative 6. So let's plug them into the formula. So it's going to be negative 6 minus 2 over 1 minus 1. So it's going to give us negative 8 over 0. When you have a 0 in the denominator, it's undefined. So that's why this is undefined slope. Okay, now what's the observation again? If the two x values repeat, it's going to be undefined. If the two y values repeat, like a number 11, it's going to be zero slope. If none of the x's or the y's repeat, then you have to actually work it out. Okay. Let's move on to number 13. So number 13, it says find an equation of the line passing through the given point. So now you find an equation in y equals to mx plus b, which is called the slope-intercept form. Let's first check out, do the x's repeat? No, they don't. Do the y's repeat? No, they don't. So we actually have to do all the work. So first I need to find the slope, right? And then we're going to use a Poincare formula to find the equation. So let's find my slope first. And then we're going to use the Poincare formula, which is y minus y1 equals to m, which is the slope, parentheses, x minus x1, close parentheses. So the first step is to find that slope. So my x1 will be negative 5. My y1 will be negative 2. My x2 will be negative 4. And my y2 will be 11. So it's going to be 11 minus negative 2 in the numerator and negative 4 minus negative 5 in the denominator. I believe we did this one earlier, I think, to find the slope. But he's going to give us 13 over 1. So my slope is 13. Now, I'm going to use the Poincare formula to actually to put the equation in slope-intercept form. So my x1 was negative 5, and my y1 was negative 2. So I'm going to plug in the negative 5 for the y1. I'm going to plug in the negative 2 for the y1, the negative 5 for the x1, and 13 for my m for the slope. Okay. So this becomes positive on the left hand, y plus 2. Now here, also on the right side, it becomes positive because x minus negative 5 is positive 5. Now I get to distribute. Okay, so I'm going to do 13 times x and 13 times positive 5, which results in y plus 2 equals to 13x plus 65. Now I'm going to subtract 2 to both sides. If we do that, it's going to give us y equals to 13x plus 63. So this is the equation that we're looking for. It's in the form y equals to mx plus b, which is called the slope-intercept form. Okay, now number 14. Write the line of the graph in slope-intercept form. So in this case, guys, they give us a line. So from that line, we have to find the equation. Okay, how is it done? So solution, I need to put the equation in y equals to mx plus b. So I need to find my slope, and I need to find my b, which is the y-intercept. So let's go to the one on the left here. So my b is where the graph crosses the y-intercept, because the b is the y-intercept. So in this case, my b is 1. Okay. My b is equal to 1 right there. I found my b. Now I have to go. I have to get another point that goes through exactly to another corners in the grid. For example, I cannot use that one, nor that one, nor that one. It has to be this one here, right there. Right? And I know that my slope is positive because it's going up from left to right. So now let's see. You see, it's going to go up all the way to where the point is on the y-axis, and then I'm going to go to the right. So eventually, it went 1, 2, it went 3 up, and it went 1, 2, 3, 4 to the right. So my slope is the change on y, or the rise over the run. So my slope is 3/4. So now I got my b and I got my m. So now we plug it into the equation. So y equals to 3/4 x plus 1. Okay, now on the second one, right? So what's my b? My b is -2. That's my b. Now we notice this is going to be negative slope. So I have to find another point that goes exactly to the corner. Let me see. This in the bottom, they don't work. Let me see the ones at the top. We have to use this one here at -4, 3. Right there. So this is negative, so it's going to go down, and then it's going to go to the right. So how many did it go down from that point there? It went down 1, 2, 3, 4, 5. So that'll be -5. And it went to the right. The run was 1, 2, 3, 4. So it's going to be 4. So the slope, the m, is a rise over the run, so it'll be -5 over 4. That's my slope. So again, I found my m and I found my b. So now I can go back to the equation and plug in both variables. I mean the values. My m is -4, -5 over 4, and my b is -2. Okay, now look at the third graph here. Remember that I mentioned, guys, that the b here, guys, is going to be -3. Remember, if it's a horizontal line, it's going to be y equals to a number. Okay, so my b is 3. So the observation was horizontal line will be at y equals to b. So the answer will be y equals to -3 because the slope is 0. Now on the last one, right, it's a vertical line, and this slope is undefined. So what was the observation? The vertical line will be x equals to c, right? And c can be any number. So in this case, my c is going to be 4. So the vertical line will be x equals to 4. That's how you find the equations of the lines using when they give you a graph. Okay, now number 15. Number 15, it says find an equation of a line with the given conditions, that it passes through the point 3, 4 and is parallel to the equation 4x minus 2y equals 5. So the first thing that we got to do is we have to know what are parallel lines. Parallel lines have the same slope. Okay, so we have to determine what the slope of this equation here is, of the 4x minus 2y equals 5. So the first thing we have to do is rewrite it in slope-intercept form. Okay, which is writing it in y equals to mx plus b. After we do that, right, we're gonna know what the slope is and plug him into the equation of the point slope formula. We know that the x is 3 and the y is 4, but I'm missing my m. So here we go. Let's rewrite it, the 4x minus 2y equals 5 in the proper form. So we start by subtracting 4x to both sides. It's going to give us -2y equals to -4x plus 5. We divide both sides by -2. So it's going to give us y equals to 2x minus 5 over 2. So remember, for the lines to be parallel, they have to have the same slope. So my slope is going to give us 2. Now I got my slope, right? And I got my point. So my slope is 2. My x1 is 3 and my y1 is 4. So I'm going to plug him in there with the slope of 2. So it's going to be y minus 4 because my y1 is 4 equals to 2 because my slope is 2. And my x is 3. So all we do is plug him in. And now we have to solve for y. So the first step is that we have to do the distributive property on the right side. So it's going to give us 2 times x will give us 2x, and 2 times -3 will give us -6. Now we have to add 4 to both sides because we want to isolate the y. So add 4 to both sides. So y equals to 2x minus 2. That's my equation that we're looking for. Okay. Okay, now on number 16. Here, guys, I'm going to show you another way. Okay, this is another way to find the equation. I like to share this with my students because I believe if they lack algebra skills, this is not the right form for them. This other form is going to help them if their algebra skills are not up to standard, so they can use another method. Okay, now we know that we have the m is 2, right? And the point is 3, 4. So here I'm going to solve for b because I already know what the m is, but I need to find my b. So we're going to use b equals to y minus mx. Why? Because we subtract mx to both sides, it's going to give us y minus mx equals to b. So b equals to y minus mx. So I know what the x is, what the y is, and what the m is, right? So all we do is going to plug them in. My y is 4, my slope is 2, and my x is 3. This will give us, right, 4 minus 6, the answer will be negative 2. So I found my m and I found my b. So we plug them into the formula, and that's my solution, the equation that we're looking for. Again, I always have another method to show the students. That way they can choose what's easier for them. Now on number 16, it's finding the equation of the line with the given conditions that passes through the point 6,8, but now it's perpendicular to the equation negative 2x plus y equals to negative 3. Now, so a solution, right? First, we have to find the slope. So we have to rewrite this equation in proper form, which is y equals to mx plus b. Then perpendicular lines, they have the opposite reciprocal, or the negative reciprocal. Let me show you what that means right now, okay? So first, let's find the slope. So we're going to add 2x to both sides. So we have y equals to 2x minus 3. Okay, now if the line, if it was asking for the line that's parallel to this equation, then we use the slope as 2. But since it's perpendicular, use the negative reciprocal means if it's the opposite, which if this is positive, it's going to be negative. And then we flip it. So it's going to be negative 1/2. Because 2 is the same thing as 2 over 1. So a negative reciprocal means the opposite sign, and then you invert it or you flip it. So my slope is going to be negative 1/2. So I have my slope, I got my point. So we can use this equation, right? We plug in the proper value. So y1 is 8, my slope is negative 1/2, and my x is 6. We plug him in there, right? We distribute. And then we add 8 to both sides. So that's my equation. Y equals to negative 1/2 x plus 11. And you can use it the other method too, like the y equals to mx plus b. We can solve for b by b equals to y minus mx. Now for number 17, it says to evaluate. So we're going to evaluate the function x squared minus x plus 4. We're going to evaluate it at negative 2, at 5, at x plus h, and this is called the difference quotient. Okay. So let's do a part. So for a part, it just means to plug in negative 2 for every x. This will give us 4 plus 4, 4 plus 2 plus 4, which will give us 10. So f of negative 2 is 10. This means when x is negative 2, y is 10. Now for b part, we're going to use f of 3, evaluate f of 3. That means we're going to plug in 3 for every x. Oh, this is supposed to be a 5, guys. I made a mistake here. We're looking for 5, right? So this here is supposed to be a 5. My bad. So I'm going to plug in 5 for every x. It will give us 25 minus 5 plus 4. It will give us 24. So when x is 5, y is 24. And again, here I made a mistake. I put a 3 instead of a 5. Now comes find f of x plus h, which means I'm going to plug in x plus h for every x. I'm going to plug it in here for the squared, and also here. Now I have to simplify or multiply the binomial x plus h times x plus h. So I'm going to do it here on the right side. So x plus h squared is equal to x plus h times x plus h. This will give us x squared because x times x will give us x squared. X times h will give us xh, and then h times x will give us xh, and h times h will give us h squared. This gives us x squared plus 2xh plus h squared. So this is going to replace the x plus h squared. Now here we're going to distribute. This is like a negative 1 here. So negative 1 times x will give us negative x. Okay. This will give us, let me go back here. This will give us negative x minus h plus 4. So f of x plus h, the result is x squared plus 2xh plus h squared minus x minus h plus 4. Now I'm going to carry this over to D. Right? Remember we had got that for D right now. You see I'm doing the same thing as before. Remember we got the same thing. So I could have got what we got in the previous one, right? And you use it for D. So this is f of x plus h. But now I need to find f of x plus h minus f of x, which is the second step. So I already know that x squared plus 2xh plus h squared minus x minus h plus 4 is a result from finding the f of x plus h. Now minus my f of x. My f of x is my original function, which is x squared minus x plus 4. Now here what I did, I took out the parentheses, so I just brought it down. And here with the negative, I distribute the negative 1. Like negative times an x squared will give us negative x squared. Negative times a negative x will give us a positive x. And negative times a positive 4 will give us a negative 4. Now here, guys, I tell my students, this is like a hint. The term without an h will be eliminated. Okay, and if you at the end, if you have a term that doesn't have an h, we did something wrong on our algebra. Okay, so that's like a heads up. Here we go. Let's start here. Does the x have an h? No. So somewhere it's got to cancel or be eliminated. You see, and here it is. Does the 2xh have an h? Yes. So it's going to stay. Does the x squared have an h? It stays also. You see, like I said, every term that doesn't have an h must cancel, must be eliminated. Here we have negative x. Here we have positive x. So those also are eliminated. The h is okay. So the 4, right? The 4 doesn't have an h, so it'll be positive 4 minus 4. It will also be eliminated, which means the result will be 2xh plus h squared minus h. If you notice, every term has an h. This is critical because now we have to cancel the h on the bottom here on the denominator. So the f of x plus h minus f of x, the result was h, 2x plus h minus 1. Divided by h, the h divided by h will give us 1. So this is my result, 2x plus h minus 1. Okay. I believe let's do another example like this one, but a little bit more simpler. This is number 18. See, we have find the difference quotient of f of x equals to 2x minus 3. Solution, again, we have to find first f of x plus h, which means I'm going to plug in x plus h for every x. Okay, I'm going to plug it in there. So plug in my x plus h for the x's, and now we distribute. Will give us 2x plus 2h minus 3. That's like step 1. Now step 2 is going to be do the whole numerator on the difference quotients formula. So it's going to be f of x plus h minus f of x. My f of x plus h, I got it in step 1, right? So we just bring it down. It'll be minus my original function, which was 2x minus 3. Now here, right? So we just have 2x plus 2h minus 3, but minus the original function, we have to distribute the negative. So negative times a 2x will give us a negative 2x. Negative times a negative 3 will give us a positive 3. Now here's where the observation takes hold, right? The observation or the hint. The term without an h will be eliminated. Does this have an h, the 2x? No, right? So it has to be eliminated. And sure enough, here's a negative 2x. So the 2x minus the 2x, they cancel each other, or they're eliminated. This 2h has an h, so that one's got to stay. And if you notice, we have a negative 3 and a positive 3. By combining those like terms, those will also be eliminated. So the result is 2h. Now comes the last part, right? So the numerator, the f of x plus h minus f of x, the result was 2h. Now 2h over h divided by h is equal to 1. So 2 times 1 is 2. So this is my solution. Okay, now number 19. Number 19 is how Our problem is related, to the real world, okay? And again, all we're doing here is trying to find the equation of the line. So this is number 19. It says a manufacturer's suggested retail price, which is the MSRP, for a new base model Toyota Prius is $25,035, and it is expected to be worth $14,115 in 4 years. So here, guys, this is like three parts. The A part, find the linear depreciation function for this car. Estimate the value of the car in 5 years from now. And finally, C, at what rate is a car depreciating? So from the word problem, we have to come up with 2 points. Okay. So the first point, right, is going to be 0 and 25,035. Why? Because when the car is brand new, right, it hasn't been driven yet, so no time has passed. So that's why my X is 0. And the original price is 25,035. So then the X is 0 and my Y is 25,035. So this is my first point. Now my second point, right, so it's going to be 4 for the X and 14,115 for the Y. So that's my second point. Now I need to find the slope and y-intercept. So for the slope, right, let's call this, right, this is x1, y1, the 0 is x1, the $25,035 is y1, the 4 is x2, and the 14,115 is y1. So it's going to be 14,115 minus 25,035 over x2, which is 4, minus x1, which is 0. This results in the slope being negative 10,920 divided by 4, which will give us negative 2,730. So that's my slope. Okay, now let's put it in b equals to y minus mx to solve for b. But like I tell my students, remember, guys, from when we were graphing, that the y-intercept, or the b, right, was when x was equal to 0. So my b is 25,035. Okay, but let's assume that you guys didn't know that. So this is how you find the b, right? So I'm going to use the 0 for x and the 25,035 for y. So plug them into the formula, right? So we got the y, which is 25,035 minus my m times the b. So my b will be 25,035. So that's my slope. That's my b. Plug him in there, and we got my equation. So the equation will be f of x equals to negative 2,730x plus 25,035. Now for b part, estimate the value of the car in 5 years from now. So in 5 years, all we do is evaluate f of 5, which means I'm going to go to the function that we just got, and we're going to put in 5 for every x. So the answer will be 11,385. So the car will be worth 11,385 in 5 years from now. Now for part C, it's saying at what rate is a car depreciating? Here's where a lot of students make a common mistake. This means what is my slope, right? But if you notice that the word depreciating, it already means that it's going to be negative. So you don't have to put negative. You say that it's depreciating at $2,730 per year, right? Because the depreciation means it's already negative. And a common mistake that students make, like I repeat, they put negative $2,730, which is not correct. You have to put positive because they're depreciating it means that it's negative. Okay. Now number 20. Number 20 is about revenue, profit, and cost functions. Okay. So it says a company manufactures 65-inch smart TVs that sells to retailers for $500. The cost of making X of these TVs is C of X equals to 300X plus 213. So this is my cost function. My revenue function is how much do the items sell for. If you notice, right, here's what they sell for is $500. right? So then, but you have to write a function, right? So you're going to put r of x equals to 500x. You have to put it just the way it is here, because if you don't put r of x, it's not a function. You have to put r of x equal to 500x. And x means that if you sell 1, right, all you do is plug in 1 for the x, or evaluate r of 1. If you sell 2, right, it's going to be r of 2, so it's going to be 500 times 2 and so forth. That's why this is a function that they want. Now for part B, the profit function is equal to the revenue function minus the cost function. So let's plug in the 500x for the revenue function, and let's plug in 300x plus 213,000 for the cost function. So here I'm going to distribute the negative. This becomes P of x equals to 500x minus 300x minus 213,000. So we can combine the 500x minus 300x. It will give us 200x. So this is my profit function. P of x equals to 200x minus 213,000. That's the answer. Now for C, it's saying what's the profit of selling 2,500 TVs? So for C, we're going to evaluate P of 2,500, which means I'm going to plug in 2,500 for the x on the function. All right, so I'm going to plug it in right there where the x is. So it's going to give us 287,000. So the profit of selling 2,500 TVs is going to be $287,000. That's how we do these type of problems. Now number 21. Number 21 is saying to find the vertex, axial symmetry, y-intercepts, and x-intercepts of the function. So if it's in this form, right, to find the vertex is going to be negative b over 2a and f of negative b over 2a. This means that this is how you find the x value of the vertex. Now to find the y value, you plug in what you got for x, plug it into the original function. The axial symmetry is very simple to get, right? Once we get the vertex, we also found the axial symmetry, which will be x equals to negative b over 2a. Now the y-intercept, you can get the y-intercept without doing no work. The y-intercept is always a c. Whatever the c is, that's the y-intercept. And for the x-intercept, you have to know how to factor or use a quadratic formula. Okay? Now, so let's find the vertex. We know that my a is equal to 1 and my b is 10. So let's plug them into the formula. So it's going to give us negative 10 over 2 times 1 is going to give us negative 5. That's my x part of the vertex. Now to find the y part, I'm going to evaluate the function at f of negative 5, which means I'm going to plug in negative 5 for every x on the original function, which will be here, negative 5 and negative 5. This will give us, what, 25 minus 50 plus 9. The result will be negative 16. So my vertex will be negative 5, negative 16. Remember what I said? The axial symmetry will be the x part of the vertex. So the axial symmetry is going to be x equals to negative 5. The y-intercept is very, you can get the y-intercept without doing the work. The y-intercept will be the c. In this case, the y-intercept will be 9. So it's going to be 0, 9. Now for the x-intercept, for the x-intercept, we have to factor. So we're going to let the equation equal to 0, which means we let y equal to 0 and solve for x. So here, guys, it's going to be, the signs are going to be the same, and it was going to be positive. So we get the factors of 10. We have 1 times 10. The factors of 9, 1 times 9 and 3 times 3. But when you add them, it's got to give me 10. That's why this is my combination. So then we let them both equal to 0. And then we solve for x. So x equals to negative 9 and x equals to negative 1. These are my intercepts, so it's going to be negative 9, 0 and negative 1, 0. This is how you find the vertex, axial symmetry, y-intercept, and x-intercept if it's in this form, in the ax squared plus bx plus c. What happens if it's in the other form, which is called the vertex form? Now, if it's in this form, right, the vertex is very, you can get the vertex without doing no work, and also the axial symmetry. Okay, this is my vertex. the axial symmetry will be x equals to h. For the y-intercept, we're going to let x equals to 0 and solve for y. And for the x-intercept, we let y equal to 0 and solve for x. So my vertex is going to be -3, -16. That's my vertex. If you notice, because where you have x minus h, if it's minus 8, then it's going to be positive h here. And for the k, it's going to be how it is. So in this case, if it's positive here, it's going to be negative here for the x part of the vertex. So we have -3 and -16. The axial symmetry will be x equals to -3. Now for the y-intercept, we're going to let x equals to 0 and solve for y. Right, so 0 plus 3 will give us 3. 3 squared will be 9. 9 minus 16 will give us -7. So my y-intercept will be 0, -7. Okay, now for the x-intercept, we're going to let y equal 0 and solve for x. So in this case, I'm going to add 16 to both sides. So we got 16 equals to parentheses x plus 3 squared. Now to solve for x, we're going to take the square root of both sides. Okay, now I put the x plus 3 on the left and the 16 on the right. So every time that we take the square root of something, right, if we take the even root, you put plus or minus. If it was the odd root, you don't put plus or minus. In this case, it was an even root because it's a square root. So the square root cancels the square, so we have x plus 3 equals to plus or minus 4 because the square root of 16 is 4. Now we're going to subtract 3 to both sides. So we get x equals to -3 plus or minus 4. So we're going to have x equals to -3 plus 4 and x equals to -3 minus 4. So we have 1 and -7. So my x-intercepts is going to be -7, 0 and 1, 0. These are my x-intercepts. Okay, now I think I have one more problem to do. Let me see, what time is it? Yeah, we got time. Well, this is how you apply quadratic functions in real life problems here. This is number 23. It's saying the revenue for McDonald's Corporation in billions of dollars for the years 2010 to 2015 can be approximated by the quadratic function, which is R of x, stands for revenue, equals to -1/2 x squared plus 13x minus 57, where x equals 10 corresponds to the year 2010. So for A part, they want us to find the vertex. For B part, this is supposed to be in what year? And what year during this period was the revenue at a maximum? And for C part, what was the maximum revenue to the nearest billion dollars? Okay, here's the solution, guys. Once you find the vertex, the x part of the vertex will help you for part B, and the y part of the vertex will help you for part C. Okay, so let's do part A first. My A is -0.5 or -1/2, and my B is 13. So then my formula, so negative, right? So I'm going to plug in 13 for B. I'm going to plug in -0.5 for A. This gives us 13 because -13 is on the numerator, and the bottom 2 times -0.5 will give us -1. -13 divided by -1 will give us a positive 13. Now I'm going to evaluate the function at 13, R of 13, which means I'm going to plug in 13 for every x on the function, on the revenue function. We put in the calculator, so it's going to give us 27.5. So for A part, that's my vertex. So for A part, the vertex will be 13 and 27.5. Now for B part, it says in what year during this period was the revenue at a maximum? Here we go back to the function to the right here where it says for x equals 10 corresponds to the year 2010. If x was 13, if x equals to 13, right, then x equals 13 corresponds to the year 2013. So for B part, in what year during this period was the revenue at a maximum? The answer will be in 2013. Okay. Now for C part, it will say what was the maximum revenue to the nearest $1 billion? So the y part of the vertex will be the maximum point. So round it off, to the nearest $1 billion is going to be 27.5, runs up to 28. So the maximum revenue will be 28 billion. I believe this is it for this exam review. I want to thank you for coming. If you have any questions, please let me know so I can give you clarification. You guys okay?
All right, thank you very much, Mr. Isasi, for that wonderful presentation. Just a quick reminder to join us every Friday for the Happy Math Hour at 11 a.m. Next week, we will have Math 1314 standard form of quadratic equations and graphing. And for this class, we will have writing exponential equations into logarithmic form. Remember that you can always watch this recording of this video by clicking on the button up here on your upper right hand, and also going into our YouTube channel. Please give us feedback on this presentation and other future presentations by clicking on the feedback link that's in the chat. And I would like to thank you for joining us today. So thank you, Mr. Isasi, for a wonderful presentation.